So quite quickly to the JARVIS Airport Digital Assistant. We will have the time to elaborate tomorrow during the open day for the project. Therefore, the Airport Digital Assistant is part of a package under JARVIS that Melina tomorrow will present to us. For three ATM digital solutions. The digital assistant refers to pilots, refers to ATC operators, and to airport operators in that respect. Therefore, we're talking about a very big project with many organizations. I leave that to Melina for tomorrow. Coming to the airport digital assistant, what was the vision? What was the context? The context for us was to demonstrate the AI capabilities across the whole spectrum of airport operations. And across the whole spectrum includes the safety-related functionalities as well as the operational throughputs. The last few years, we tend to provide more emphasis on the operational throughput. But we believe that the research pipeline should be balanced since safety and security is the foundation on which we are performing operations, and operational throughput is the performance related areas. We need to implement performance-based operation, and as such, we try to create a package of digital safety solution as well as operational throughput airside and landside. We started with one solution, which ended up to be split in 4 solutions, so that was an added value provided within the context of the project. The 4 solutions for the project are better depicted here in this sketch, where we can see that we have solutions which focus on the so-called the taxiway incursion, detection of taxiway incursion. We are referring to the incursion induced by the so-called non-cooperative vehicles. We are not talking about transponders, we are talking about vehicles which operate on the service roads of the aprons and happen to move in a perpendicular manner through the service roads which intersect taxi lanes or taxiways. So we try to find a way to detect these movements. Therefore, this was the first area of concern for us that became a research context. The second one, in terms of safety, had to do with a rather critical area that a lot has been done in the past by many providers, but none has been done in terms of a complete ATM solution. So you might have heard a lot of research efforts in the past for FODs as well as for wildlife detection. The latter has been developed within the context also of wind turbines, as per which the industrial partners try to find a way to stop the turbines when a flock of birds is approaching the wind turbine. In our case, the AI technology through the sensors, practically the cameras at this stage, will give us the focus on how to detect the flock of birds, which at that point of time creates a problem on the runway operation. The same also applies for FOD. I don't believe I have to say too much about FOD because we all understand that this is the most critical safety factor in runway operations. When we move towards the operational throughput, we try to touch on the TOBT monitoring before the start of the turnaround, and that's the big thing, not during the turnaround. You will see that later. And on predicting the passenger flows as part of the overall AOP. Why? Improve end-to-end operational performance, safety-wise and performance-wise, and in that respect, improve our safety throughput and our performance throughput with a direct effect of max experience. Which are the areas? We said already, taxiway incursions, FOD and wildlife on the runway, aircraft turnaround, and passenger flows. How do we do this? Through AI-based technology, with the most important element being the human-AI teaming and how we make this assurance through a concrete framework. Of course, a lot of benefits we will elaborate tomorrow during the open day. The challenges had to do with the design for ensuring a trustworthy system in terms of safety and security. The human AI teaming has taken quite a lot of our efforts in the course of the project, while also the big data management and the infrastructure required to make all this data flow from one side to the other was a very big challenge. And just to give you a feeling of how many secure connections had to be created, what it takes in order to create a digital twin so that not to burden the operational systems, and how this all worked together. It was a major thing that was delivered by our industrial partner and our internal IT colleagues and contractors. Just to give you a feeling about what is taxiway incursion. Taxiway incursion, you can see a turboprop aircraft which is taxiing on this specific taxi lane, and on the right-hand side you can see a GSE moving on the service road. The GSEs, as well as the service vehicle drivers at all airports, are trained according to a rigorous program. It happens everywhere, so we're not reinventing the wheel. But these partners are not ATM partners, and therefore we try to find a way to make them ATM partners, or to try to get this information and feed it within the pipeline of ATM operations end-to-end. So that was not an easy thing to do. We will come back tomorrow on this, but just to have for you the concept of what is the detection of a vehicle or GSE on a service road which happens to be perpendicular due to the geometry of the apron at many airports, not only here. For the detection of FODs and the same also of wildlife activities, we did the following. We simulated the runway on one portion of the taxiway. You understand that it would have been extremely difficult to suspend runway operations for the sake of research. So we used a portion of the taxiway at a certain point of time, and objects of specific nature and size were thrown so that we could see how the system, how the sensors could, what data they could collect and how this could be processed. For the sake of avoiding confusion, we were trying to focus on the first level of alert, just have the alert. We are not going to the depth of how this could be integrated in future HMIs and so on. For the detection of birds, again, we focused on this portion of the taxiway which was simulated the runway. Again, we'll come back tomorrow. And as regards the operational throughput functionalities, I know, and we are all doing work in terms of the timestamps during the turnaround activity, but we believe in this project that these solutions, which are currently industrially available, and a lot of research has been done in the past in that respect, give us all the available data probably to work in a pre-tactical or even in a strategic manner. And in our solution, we are not looking in the course of the turnaround, we are looking before the turnaround, before the aircraft is on the stand. That was the basic thing in the solution. So we try to identify the deviations on nominal turnaround before the start of the turnaround. So if we're in a position to identify how the turnaround would prove to be before the aircraft comes to the stand. Why? Because we have a similar profile from similar turnarounds of the same aircraft type at the same area of the apron, that could give us an early detection of what to expect. And we believe this is where the value is. Predict the turnaround before the turnaround. And then we close the loop with the passenger flows. We can have the best, the perfect ACDM system in the world, or the best initial or extended AOP in the world. At the end of the day, a ready aircraft, from the airside point of view, it's not quite certain that it will leave the stand if the passengers are not at the gate. Therefore, what we try to do is extend the work that has been done in previous cycle of CESAR through a more quantitative monitoring of the passenger flow, so that we could work on the so-called landside TOBT in a very plain language, and combine this with the airside readiness. This was the context of this specific solution that we will definitely elaborate tomorrow. Very important. I talked earlier about the AI assurance. I believe Melina has also a slide, so I will not take too much time about this part. On the FOD side, we work together with the EASA, together with other solutions, in order to see how we can classify the process of AI assurance for this specific use case, and try to come up with the requirements according to the existing EASA roadmap for AI assurance. We did that. We developed a scope as per this roadmap, according to which I believe we contributed to a certain extent on how we can start planning our work for any AI-related system which will come as an operational tool, either safety-wise or throughput-wise, in the years to come. Thank you so much. I believe we'll have the time to elaborate tomorrow on the JARVIS solution. Thank you.